Hello, build stuff. Hello, boys and girls and gender transcenders. Yes, down there. So yes, welcome to Programming's Greatest Mistakes with me, Rendle. Just the one name now, because I'm that cool, basically. Demarcation, exactly, yes. No, this is Programming's Greatest Mistakes, but before we start, I just want to do a quick content reassurance, okay? Nobody dies in any of these. That's not funny when people die, and this talk is, well, I can't not be funny, it doesn't work. So no one dies. More specifically, there are no aeroplane crashes, because the last thing you want to hear on the last afternoon of a conference when you're about to head to the airport is, hey, Boeing. So let's not. So yes, however, quick content warning, the first mistake that I'm going to talk about necessarily, dramatically, involves swearing. It involves the second worst of the swear words. And so if you're particularly sensitive to that kind of thing, like you're American or something, then you should probably fuck off. So let's get to it. I'm going to start, this was my mistake, and I just want to, it's important to have humility and not to just be criticizing other people. So this one was me. This happened in the 90s. I was working at a company. We made membership management software for non-profit organizations in the UK. And we had this insanely sophisticated query engine, which allowed you to query on every single possible aspect of data, whether people had attended events and how much they paid for that, all these sorts of things. And these queries, people had hundreds and hundreds of criteria points in these queries. And so we had a way that they could save their queries. And they were saved in .med files, med files we called them. Can't remember what it stood for, but that's what they were. We released a new major version of the software, which would load the old version of the med file, upgrade it, and then save it back again. Except somebody forgot to use file create and instead chose file write, and that meant that it just changed it basically completely corrupted these files. And so the support guy came to me and said, Mark, the new version, it's fucked up the med files. And I'm kind of like, okay, what do you want me to do? He went, here's like one of the files, can you see if we can fix it? Because they didn't have backups, or they attached their backups to the filing cabinet with magnets, which is that's a whole other story, true story. And so he went, I looked at it and I went, yeah, no, we can recover that. And I went, so you want me to like write a little med file unfucker, yeah? And he said, yes, please. And so I went, cool. And so I booted up Visual Basic 6. I'm not proud of it, but that's what it was. And this was kind of like, you're still in the holdback, the old days where file names had to be 8.3. And so I had to come up with a name for the project, and because it was in my head, I called it Unfucker. And then I kind of ran with that, and so it brought up a file open dialog, and the title in that was choose the file to unfuck. And then it sort of showed a little dialog box, and it said, there'd have a button that said unfuck now. And then it briefly displayed a progress bar that said unfucking file. And then at the end, it went file successfully unfucked. And I gave this to the support guy, and I thought, because, I thought, it's funny, it'll make him laugh, it'll brighten his day up a bit, he's having a bad day. So there you go, I've done it, test it to make sure it works on a few of the files that people have sent you. And then I didn't hear anything about this for like a couple of days. And then when I did hear about it, it was because I was called into the CEO's office, and it turned out that I can only assume the support guy hadn't actually run the thing, or he couldn't read. One of the two. He released it. He sent a file, and I'm not kidding, called unfucker.exe, put it on a floppy disk and sent it to the customer, because this was how we did things in those days. They took the floppy disk out of the thing and they gave it to the director of the Confederation for British Industry. who ran it and was not happy. And yeah, the only reason I didn't lose my job was because I was the only programmer in the entire organization who understood about 40% of the code that we had, because I'm really clever. No. I just written some very, very strange C++ things that made Windows 95 applications look like Windows XP applications. They couldn't sack me. Eventually, they managed to get rid of me by moving all development over to VB.net, and I quit. But no, the thing that I love is that I've done a lot of talks, I've done a lot of things, I've released open source software with like millions of downloads on NuGet. This is the thing that I am known for. Dead naming myself a little bit there, but yes, I am now Medfile Unfucker Rendle. It's a much better first name. I really like that, and it's gender neutral, which is cool. So yes, moving on. Y2K. So this is probably one of the most famous mistakes in history. And the thing that you have to understand about Y2K is originally it wasn't a mistake. And did anyone go to Eli's data storage talk earlier on? It was, yeah, fascinating talk. And back in the 1950s and 60s, when we were first starting out building software, data storage looked like this. This is a punch card, and it can store 80 bytes of data. And so we were really limited. This is the core memory that Eli mentioned. This looks like Shreddies, if you know what Shreddies breakfast cereal is. It's like memory knitted by nanas. And this stuff was like $1 a bit when they first launched it, and then it went down, it was like $1 a byte for quite a lot. It was really, really expensive because it's completely handmade. And so it made sense that you wanted to shorten data, you wanted to compress data as much as possible. And this is right in the middle of the 20th century. And so it was pretty obvious that the first 2 digits of the year were going to be 19. And so everyone will just leave them off then. It'll be fine. And so this is the COBOL representation of a date. WSTX date is a pick 9, which means it's a string, effectively, but it can only hold numeric digits, and it's 6 characters long. And it made perfect sense. This is Bob Beamer. And at the point when we were rolling out software written in COBOL that used this sort of shortcut to save memory and space, Bob went, okay, this is fine for now, but we are going to want to come back to this in like 10 years or something, because we're going to get to the point where we're doing pensions that don't mature until the 21st century. But this was, the 21st century seemed miles away, and it was going to have flying cars and teleporters and robot butlers and all sorts of things. And so we went, yeah, okay, Bob, yeah, we will, we'll come back to it. And then at the end of the 1970s, Bob was still going, we really should start worrying about this. And at the end of the 1980s, he was still saying, please, can we do something about this? And in 1993, 94, the computing world finally went, yeah, no, Bob's right, we should really solve this problem, because we are now having like passports that expire in the 21st century and credit cards that expire in the 21st century. And so for the last sort of 5-6 years of the 20th century, we didn't do anything in computing except fix the Y2K bug. I was part of a team that rewrote a massive COBOL system in something called Infomix 4GL. That was future-proof. While we're fixing the Y2K bug, we might as well rewrite the entire system in something that supports proper dates. And so this is a kind of conservatively estimated cost of the Y2K bug, $500 billion we spent. And the mistake in this case was just leaving it to the last minute, not planning for it, not being ready for something that it was very obvious was going to happen. And so, of course, we learned from this mistake so that we wouldn't, oh no, wait, we didn't. So yes, this was the Y2K22 bug, where somebody at Microsoft working on Exchange had decided that they were going to store effectively a date written out in digits, but put it into an integer type. And so when we hit 2022, you got the 22 at the start there, and you can't put that in a 32-bit integer. It's 2147 something. And so, yes, Exchange crashed, and Exchange on premises, Exchange in Office 365, the whole thing was down for like 3 days while they fixed this. We have Y2K38. This has actually been averted. Unix systems, Linux systems are not going to melt down in the year 2038 because we took a 32-bit signed integer, which was being used to store the time, and we added another 32. We didn't make it 64-bit. We added another thing that goes alongside it, apparently. I'm not quite sure what happened there. But my absolute favorite of all these bugs is the Kennel Club. The Dog 38 bug, which I found out about from Matt Parker's Stand Up Maths channel on YouTube. So the Kennel Club is where, in the UK, if you have a fancy dog that you've paid over £1,000 for, and you know who its parents and grandparents and great-grandparents are, and it has a show name in case you want to go and say, is my dog better than your dog? I don't know, I'll get a rosette, and so on. So you have to register your dog with the Kennel Club. And if you have two dogs of the same breed and you want to give them the same name, then the second one is Fiddlesticks McCaramel Muffin the second. And then if there's another one with the same name, it's the third. And obviously some breeds are more common than others, and part of the name usually comes from the family ancestry and so on, and so you do get the same names popping up. And eventually they got to the point where somebody tried to register the 38th dog of a particular breed with a particular name, and the database crashed. Can anyone who hasn't seen this talk before or seen the stand-up maths thing have a guess? How were they storing that number in a way that it would overflow at 38? I'll give you a clue. It's a very old way of writing numbers. Roman numerals. Okay? Because this is how it's printed on the certificate, this is how it's displayed on the screen, so that's how they stored it in the database. And Roman numerals, you can go up to 37, that's XXXVII, that fits in 6 characters, but 38 is XXXVIII. Actually, after this, you can go a lot further, and you're still back down under 6 characters, but 38 is 7 characters long. And they fixed this by doubling the length of the field in the database. They didn't switch to like just storing it as an integer or something. They just went, just add more characters, it'll be fine. So yes. A more general programming mistake, just the entire concept of enterprise software. I hate when people use the dictionary definition. Unaccustomed as I am to public speaking, the dictionary defines marriage. But in this case, I found this definition, and I think it's just too perfect. A business plan or project, especially one that is difficult or that may fail or lose money. And that just, to me, that describes enterprise to a T. And there's a really good reason why enterprise projects fail or lose money, and it's the way that they are run. Because we have things like Agile, and we do Kanban, and we have sort of cards stuck to a wall and all this sort of stuff. Enterprise don't do that. This is how enterprise do Agile. This is the scaled Agile framework. This is the scaled Agile framework for lean enterprises, okay? That's like for short trees. And if you look on here, so is my laser thing working? No, it's not. Never mind. Yeah, but I'm going to move over here. So we got all this stuff that's going on here, and we got a solution backlog and a program backlog and team backlogs and continuous exploration and integration and deployment and context and product owner, and down here we got this little splodge of people, programmers. Yeah, people actually putting code into source control and into production. Kind of, they're not even labeled. They don't even have a... It's an abject afterthought because enterprise software development is not designed to produce software. It's designed to insulate everybody involved in the project from blame or accountability when it ultimately fails. Yeah? You don't need programmers for that bit. What you do need is mountains of paperwork and audit trails. This one's, yeah. So this is insane. This is psychotic. This is Auto-Scrum, which is Accenture's model. I've done this talk and then, like, in other places and walked out and seen Accenture, like, literally. They got a booth right outside the door, and I'm just kind of like, but again, it's the same. We've got all this stuff going on here: inspect and adapt, and complex systems and backlogs and more complex systems, and it's just repeating iterative feature development. FROP. How is platforms iterative feature development? How is the acronym for that FROP? I just don't even. But again, here we are, down at the bottom here, Agile Team. And any Star Trek fans will notice that 2 of them are wearing red shirts. They are not making it to the end of this project. But all of this pales into insignificance next to the monstrosity that is Deloitte's Agile Landscape, which is the metro map of hell. I mean, literally, there's a circle. Dante is lost somewhere in there. The Scaled Agile Framework and Accenture's Auto-Scrum are but stations on the metro map of hell. This is why enterprises, governments, the biggest organizations in the world can't get anything done. This is why banks are still running on COBOL in 2024. I dread to think if I went and added it all up, all the failed government projects and banking projects and every other, it would be trillions and trillions of dollars that has found its way into the pockets of consulting firms who had a paper trail to prove that the failure of the project was definitely not their fault. Sometimes programming errors make it into hardware. That's really fun. Because essentially you can't like lay out the transistors and everything manually. You write code, and then that code is automatically turned into transistors and things by the manufacturing process. And Intel, the Pentium, this is the Pentium, the original first one. This was the first CPU that Intel sold where every single one had a floating point unit built in. The 486 had one with a floating point, but also the SX option, which didn't. The 386 didn't have a floating point unit. The Pentium was the first one where everyone got floating point, and we were all very excited because Quake had just come out, and the Pentium could run it really, really, really well. So, question. What is 4,195,835 divided by 3,145,727? Too slow, it's 1.33382. Except the Intel Pentium calculated it as 1.33374, which is obviously a completely different number. You'd be amazed how quickly somebody found this. Like, just really quickly, just so quickly, you're like, did Intel even test this? And so Intel initially said, if you can prove that this is breaking your work, if causing you a problem, we will send you a fixed version. And people went to such lengths to prove that it was causing a problem. Intel eventually just went, yes, we'll just send you a new one, fine, at a cost of $475 million. And this was in the 90s when that was a lot of money. Okay. The next one, we have a dollar value that was put on it by the guy whose fault it was, and that is, of course, Null. So yes, null reference exception, dereferencing error, undefined does not have a function called spl, whatever, null. This is the guy who invented Null. This is Tony Hoare. He is a fellow of the Royal Computer Society in the UK. He is insanely smart guy, okay? And what Tony Hoare was working on was a variant of Algol called Algol W, which was the first programming language to have the concept of records, okay? Prior to this, the data values that we were storing were strings and numbers, essentially, maybe the occasional Boolean. This was the first time we had something that was kind of abstract. And so with a string, if there's no value, you can use an empty string. With a number, if there's no value, you can use 0, or if 0 is a valid option, then maybe -1. But when you've got a record, you're kind of going, well, what's the absence of a record? And so Tony Hoare decided he was going to call it null, and it looks like this in code, where you've got if m equals null, then whatever else. And of course, if you try and get something, and the pointer to the record is 0 or null, then you're going to get errors happening at runtime. And this is still happening to this day, despite the fact that since then, we've found multiple better ways to handle nullability, like option and maybe types. But no, we still generally rely on and fall back to null. And Tony Hoare called this his billion-dollar mistake, which I think is probably a conservative estimate. I like this one, because these fuckers deserved it. So Knight Capital was a hedge fund. And if you don't understand what a hedge fund is, I'm going to do a brief potted history of the stock market. In the 17th century, the Dutch East India Company wanted to build an awful lot of ships, sail them to India, steal their stuff, bring it back to Europe, and sell it. But building ships costs a lot of money. And so they went to all the rich people in Amsterdam and The Hague and all these places, and they said, you give us money to build ships, and then the ship goes and steals the stuff, and then it comes back here and sells it at a vast profit, and then we give you a share of that profit. And people went, yeah, that's a really good idea. Like, invest in a company, not a good company, but a good idea. So this was the original idea of stock markets. You had an idea. It's like venture capital, essentially. That was all it was supposed to be. But then obviously you get like somebody who falls on hard times while the ship is still on its way to India and needs money in a hurry, and he's got his share, and he goes to somebody else and goes, would you like to buy my share? And so the idea of trading shares became a thing, and then the value of the shares, you could get a message back from India going, we found diamonds! And they go, oh, this is worth a lot more now than it was before. I'll sell it to you for more money. And over time, this evolved into the New York Stock Exchange and the London Stock Exchange, and a thing called dark pools, where companies would actually buy premises literally next door to the New York Stock Exchange, drill holes through the wall and run fiber optic cables, and then just release incredibly highly optimized programs to run on servers in these data centers, and they would trade stocks at microsecond intervals. And just, it's only a fraction of a cent, but when you're doing it millions and billions of times a second, it adds up to real money. Just being creamed off the top of the economy and given to the 0.01%. Down with capitalism, destroy the state. Eventually, the New York Stock Exchange got fed up with this, not because it's like ethically bankrupt and morally void, but because they weren't making any money out of it. And so they said, we're going to eliminate the dark pools and essentially create light pools running on the other side of the wall. So they just, you have now they're in the stock exchange, and the New York Stock Exchange gets to take their cut. And Knight Capital had to adapt the code that was running on the dark pools so it would run on the New York Stock Exchange system. And they repurposed certain flags. And when they rolled out the software, they had 8 servers, and the software failed to roll out to the 8th server. 7 of them got the update. The 8th one didn't, and it had a flag that in the new code had been repurposed and used for something else, but in the old code, it enabled something called PowerPeg. And PowerPeg was designed to make trades as quickly as possible, buy low, sell high, and then there would be, the flag would say, stop, okay? We've bought enough, we've hit our target, and so just stop. And because of the different versions of the software, that flag never got set. And so this server just kept buying and buying and buying and buying and creating parent orders with millions of child orders attached to them. And by 10 o'clock, an hour after trading started, they had run up $500 million in trades, which a hedge fund can't afford, and they'd also actually impacted the price of about 150 stocks and taken like really crappy little stocks from about $3 up to $25. And yes, the thing is, at the end of the day, when stock trading is done, you have to pay for all the trades that you've done. And Knight Capital didn't have this kind of money, and so they had to go and raise money to bail themselves out, and eventually got bought by Goldman Sachs, and it cost them $440 million to pay off those debts, and then Knight Capital just got slowly forgotten about. Sometimes we write code and we just put it somewhere where you can't do anything about it. We fire it off on a one-way trip, and if there's something wrong with it, tough, we'll find out in time. Because in space, no one can set a breakpoint. No one gets the previous reference, which is the Muppet Show from the 70s. This one is a horror film from the 80s. I swear to God, I was in Eli's talk earlier on. They mentioned VHS tapes, and the person next to me Googled VHS and then showed me their phone and went, "Is that right?" I felt so old. Anyway, Mariner 1. One of NASA's very earliest missions, and they call this the most expensive hyphen in history. It's not actually a hyphen, it's a horizontal line. This is what Mariner 1 was supposed to look like as it soared majestically through the infinite vacuum of space towards its destination. But this wasn't actually a programming error, this was a specification error. This was analysis. This was the mathematician who wrote the equations for the programmer to turn into machine code. So on the left here, we have an R with a hyphen over the top, a line over the top, and on the right, we just have normal R. What that line over the top means is smoothed over time or averaged over time. Okay, and what this was measuring was forces inside the rocket that would vary wildly on sort of a scale. And so if you smoothed it over time, it would settle at about 0. The guy left the hyphen off. And so this person is going, does 355,262 equals 0. No, it doesn't. And if that carried on for too long, it sent an emergency distress signal going, hello, hello, I'm going to explode. And then the guy at mission control hit the big red button so that it exploded at the right time and not on its own trajectory. And so, yes, this was back in the 1960s. That only cost $18 million. $18 million in the 1960s was worth about $1 billion now, but never mind. The Mars climate orbit, so the Mariner 1 incident actually is credited with giving birth to the idea of software engineering, of applying engineering principles and checks and balances to stop software projects going wrong. And NASA generally do very well with their software, but they also deal with a lot of other companies. One of the reasons NASA is allowed to continue to exist is because companies all over the United States work with NASA, like Boeing and Lockheed Martin. So the Mars Climate Orbiter was supposed to go to Mars, orbit around it, and see what the climate on Mars was like. I mean, cold, mostly, but occasionally windy. Because they wanted to find out if you could fly a kite or something, I don't know. But yes, again, artist's impression of what it would have looked like. So, there are two systems of measurement for pretty much everything. There's the one that everyone uses, and there's the ones that Americans use because they're special and you can't be special without being different. And so, we have the total impulse calculation being calculated in pound force seconds, which is the imperial measurement of force. So that's 10p-f-s. And then the trajectory calculation, which is informed by the total impulse calculation, is done in Newton seconds, the SI unit. NASA always works in SI units because they also work with international partners like Japan and China and Russia and the European Space Agency and so forth. Lockheed Martin, very American company, no, we're going to use, I don't even know if that counts as imperial. I'm just going to call it like Bronze Age. And so yes, this is sending 10, and the equivalent in Newton seconds is 44.5 Newton seconds. And so when you have this thing sending pound force seconds into this thing, which is expecting Newton seconds, it goes, oh no, we're not going fast enough, and hits the accelerator. And then you get to this point, and the Mars Climate Orbiter comes zooming in at Mars far too fast, hits an orbit far lower than it was supposed to, and ends up as a smoky black mess on the surface of Mars, which you can see to this day. And it will be there forever, a mark of shame for Lockheed Martin. Let's not even talk about Boeing. That one, $327 million, and again, this was in the 90s, possibly early noughties, still a lot of money. And then there's, you know, that's Americans. Americans are stupid. We all know that. Hello, Americans in the room. It's, oh no, he's leaving. Excellent. You're not really stupid. You're just interesting. Words come out of my mouth. Yes. But no, we are not immune to this here. This is the Ariane 5 launch, the maiden flight of Ariane 5, where like the President and Prime Minister of France and all these dignitaries and everybody else has gathered to watch Ariane 5 launch. And here we are at T-minus 5 seconds, and the engines are just about to ignite. And there's this point where the engines ignite, but the rocket doesn't take off straight away, okay? And in the software for this rocket, there is a thing called the inertial reference system. And this only actually matters before the rocket launches, but it stays active for a few seconds after the rocket launches because it's not a precise thing, okay? And the inertial reference system uses a 64-bit floating point number, but it writes that because of system constraints into a 16-bit unsigned integer, right? This code was copied and pasted from the Ariane 4 rocket software, and yeah, possibly the worst ever result of copying and pasting code. The main problem with it was that it accounted for the velocity of the rocket, and Ariane 5 went faster than Ariane 4. And so the number that had fit perfectly happily into this integer on Ariane 4 suddenly overflowed, caused an overflow error, out of bounds read or whatever it was, and yes, they had to terminate the flight 40 seconds in at a cost of $500 million, basically, Ariane 5. So yes, taking the mickey out of all these space, I mean, you know, I've never put anything into space. It's just impressive that they ever do it, and I think we can allow them the odd mistake. So let's do another one of my mistakes quickly. I call this one the Big Rewrite, named after a Line Breakers song, and this is my inability to avoid new and shiny things, because I was halfway through a project rewriting a Gupta SQL Windows application into C# and Windows Forms, and then it hit 2005, Microsoft released WPF, and I went, ooh, shiny. And I obviously had to rewrite all the UI code in WPF, and 3 years later I still wasn't done. I had a nervous breakdown. I spent 6 weeks in hospital, then 3 months recovering. Then I went back and had a review, and they gave me a very bad performance review because I'd taken so much time off. And so yes, I think probably it cost about £100,000, but also my sanity. So yes, ask me about that sometime, and I will tell you the horrors. Okay, on to other people's mistakes. Brendan Eich specifically. Yes, JavaScript. Just JavaScript. It's just a mistake. It's actually compound mistakes, though. So mistake number one. Brendan, can you knock together a quick scripting language for a demo next week? If I could, you know, if I had a time machine, I would go back and like kill somebody or whatever. If I had a time machine, I would go back to 1 year before then and find Brendan Eich and say, don't ask me how I know this, but in a year they're going to ask you for a scripting language to put in the browser. Here is a list of things not to make it do, and just please spend a little bit longer on it. Just go, oh, I happen to have one right here, and it's gorgeous and beautiful and has static typing and all sorts of good things. But no, this went into Netscape Navigator. It was a kludge. He originally wrote it as a scheme, because schemes are really quick and easy to write, and then they said, oh no, we're competing with Java, make it look like Java. And so the original JavaScript was a scheme with curly braces and semicolons to make it look like Java, even though underneath it's a scheme, which is why it uses prototypal object orientation and various other horrible things. And then they kind of went, oh, people who aren't very good at programming are going to want to use this programming language, and we'd like their programs to work. Can you cater to those people? And so there's all sorts of weirdness in there. We have array, and you can negate array. So doing this will actually coerce array and not an array into values. That equals true. So yes, array and not array are the same thing in JavaScript. This is my favorite, b plus a plus plus a plus a equals banana. Because what you've got there is the two pluses that are together. So the first plus is add the next thing to this string, and then the next plus is essentially saying this is a positive number, and then the next thing is a letter. And so JavaScript goes, right, turn A into a positive number. I can't because A is not a number, so I will return nan. I won't crash. JavaScript's whole thing is don't crash, but if you did something, it's like if you do a divide by 0, JavaScript won't crash, it'll go, that's not a number. And so we end up with nan in the middle of our thing. So yes, and then there's all of this hell. So document.all is an instance of object, but the type of document.all is undefined. Does document.all equal undefined? No. Does it equal null? No. Does it kind of equal null though? If we don't coerce the type? Does it kind of equal? Oh yes, no, it definitely kind of equals null. It just doesn't actually equal null. Thank you, JavaScript. I have no idea. It's fun though. All right, running out of time, but I only have a couple left to go. And this is a new one. You are the first people to see this one because it only happened this year. Can anyone guess? Call it out. Crowdstrike. So yes. What happened with Crowdstrike, and why did it happen? I mean, what happened was that one day a whole bunch of people turned up to work and they turned on their computers and their computers did this, which you don't see very often. And it took a while to figure out what had happened, but it turned out what had happened was there was some software from a company called Crowdstrike that protected your PC from malicious software. Okay, and in order to do this, the Crowdstrike software had to run in kernel space. Okay, so you have two sort of places where programs can run in an operating system. Most of the software that we write runs in user space. Okay, and that's nothing in there. It's very difficult to crash the entire computer with something that is running in user space. But kernel space is where it has unfettered access to the underlying hardware. And the reason Crowdstrike software needs to run in there is because it was actually hooking into the hard disk drivers and looking at the bytes as they were read off the disk to make sure that if they were detected something that was dodgy, those bytes wouldn't make it into memory, which sounds like a worthy and valid way to write software, doesn't it? Sounds perfect. The thing is, on Linux, if you want to run something in kernel space, you have to submit it to the Linux kernel project and have it approved by Linus and various other people, or is it Linus? Anyway, him, Torvalds, and then it gets compiled into the kernel. And I mean, that's these days. In the 90s, if you wanted to plug in a new mouse, you had to recompile the kernel on Linux. So it was lots of fun. Apple You can't run anything in kernel space on Apple hardware. The Mac OS operating system, the iOS operating system, just doesn't happen. Microsoft tried to stop people from running things in kernel space. And there are two kinds of people who run things in kernel space: malicious actors, hackers, and the people who try to stop them. I'll do that way around because I don't want to give you the finger. I got complaints the last time. So yes, the people who stop them, okay? So if Microsoft made it impossible for anyone except Microsoft Windows to run code in kernel space, then neither of those people would be able to do that. Which is good that the malicious actors can't do it, but it's bad for the several corporations, multi-billion-dollar corporations, who have built a business on fighting the malicious actors. And so when Microsoft attempted to stop people running things in kernel space, all these companies filed a class action antitrust lawsuit against Microsoft, saying, you are going to put us out of business. And it's kind of just the stupidity. So Microsoft were going to fix this. They were going to make this impossible, but then they were lobbied and bullied and legally threatened into continuing to allow malicious actors to install rootkits. And by malicious actors, obviously, there I am, including Sony and whoever does the anti-cheat software for Diablo 4. But yes, these people, Microsoft had to allow them to continue doing stuff so that the people who made the software to stop them doing stuff could continue to sell that software. And so, yeah. And we ended up with this. And what actually happened was, it wasn't a software update at all, it was a data update. They released a data patch. It was supposed to have 21 fields, and it was supposed to have 20 fields, and it had 21. And so it overwrote a bit of memory that was being used probably by some entirely other part of the operating system, and the result was a blue screen of death. And my favorite thing about all of this was afterwards, after the root cause analysis and everything else, the Crowdstrike CEO released a statement which included, our analysis, together with a third-party review, confirmed this bug is not exploitable by a threat actor. It doesn't fucking need to be. It crashed 400 million PCs. I would rather have a threat actor, honestly, because at least I could probably have patched that quite, but no. Drives me nuts. Just quick honourable mentions. Heartbleed, obviously. I can't even remember what Heartbleed was at this point. It pales next to Crowdstrike, it really does. Log4j, that was a wonderful... the only thing about Log4j was how long it took somebody to figure out that allowing you to put executable Java code in log messages might be a security hole. Yeah. They got away with it for years, but it did eventually get caught. The initial Java, so the Oracle JDK and OpenJDK, their initial implementation of the elliptic curve DSA algorithm, what this does to check whether the private key and public key matches, it does a bit of maths that returns 0 if it's successful. What they didn't do was check to see whether you'd also set the public and private key to 0, and if you had, then the maths would also return 0, and so validate your inputs, I think, is the lesson from that one. Got patched fairly quickly, but yes, some security researcher somewhere made a few $100,000 for a very easy day's work. So, I'm actually doing this on time. I'm doing it on time, Dylan, aren't I? Good. Yay! Thank you. So yes, I'm going to finish with what was nearly the worst programming mistake in history, but wasn't because of one man. The Soviet early warning system. The thing that told the Soviet Union that there were missiles headed for strategic targets. This is Lieutenant Colonel Stanislav Petrov. And he was at his station one day in 1983, September the 26th, 1983, and all the lights started flashing and the sirens went and everything else, and it said, there are 5 ICBMs inbound from the United States to strategic targets in the Soviet Union. Launch a counteroffensive immediately. And Stanislav had a choice to make. He could either run this up the chain of command and essentially cause World War III and the end of all life on this planet, Or he could kick the computer and go, why would the Americans suddenly fire 5 missiles at us? I don't think this is real. And after the fact, when they investigated what these 5 missiles actually were, they were sunlight glinting off clouds. Everything nearly ended that day in 1983 because the Soviet computers identified sunlight glinting off clouds, probably in a very beautiful way, if anyone had been there to see it, as missiles coming to blow up Moscow and Stalingrad and everywhere else. And so this man, if anyone can claim to have single-handedly saved the Earth, it is Lieutenant Colonel Stanislav Petrov, and we should all be grateful to him for knowing that computers suck and the people who program them are idiots. Thank you, Stanislav.